right? Then with that set up, now I can define the incremental refresh policy, right? So that's all you need to do here in the Power Query editor. So I'll come out of here. And now with that set up, I can come to the table and say, this is the new option that is going to be shipping. And I can define my incremental refresh policy, right? So a couple of things to point out here. This will only work in Premium, right? It will only work in the service. You define the policy here in desktop, but it only actually takes effect once it's published to the service, right? So even with this policy defined, I run a refresh here in desktop, it's still just 1 day of data. Again, I'm not going to get 10 years of data in desktop. But then when I publish it to the service and then I refresh, that's when it's going to load all the history. Make sense? All right. Currently, we don't allow you to round trip these models back to desktop. Again, once we open up once we remove the 10 gigabyte limit, these things could be like 50 gigabytes and you wouldn't be able to open it in desktop anyway. Long term, we'll figure out a solution for that, maybe some kind of metadata only PBIX download. And then I'm defining this policy for this particular table, right? If I go to a table that isn't filtered by those parameters, it detects that this table is filtered by those parameters. This table therefore qualifies for incremental refresh. And when I first open it up, it's disabled and I just toggle it to enable it. If I go to a table that isn't filtered on those parameters, it's disabled and I can't toggle it. And there's a message here saying you have to set up the parameters and here's a link to tell you how to do it, all right? So with the parameters set up, I can enable it, and then I say, I want to store 10 years of data in total, right? And therefore, the first time it's refreshed in the service, it will load all 10 years of data. Subsequent refreshes will only load the last 10 days of data, much more efficient. All right, makes sense? And as you roll forward, if you run the refresh every day, it will generate a new data and then refresh the previous 9 to give you a 10-day incremental range. Right? Does that make sense? Okay, this is the most complex thing. This alone was like 2,000 lines of code in analysis services. This has been condensed down to a couple of little drop-downs, which is going to unlock much bigger data sets in Power BI Premium, right? And really, this is 90% of what you need to know, or in many cases, this is all you need to know. Yes, go ahead. Yeah, yes, please.
Do you utilize partitioning for this in any way?
Good. I'm going to, depending on how techie we want to go, I can go really deep in a minute and show you the partitions that are getting generated. So currently it's a bit of a black box. So, but once we open up XMLA endpoints and Tom and Timsel, you'll be able to connect with SQL Server Management Studio and you'll be able to see all of the partitions that are generated for you automatically. Right? Just like we used to in the good old days, but it's all abstracted for you with these little drop downs. So yes, absolutely. It creates and manages partitions for you. It manages the rolling window. It deletes old partitions that fall out of range. It does automatic partition merging to improve compression. It absolutely uses partitions. Yes. Any other questions? Yes, go ahead, please.
Is it supported with Oracle Data Source?
Yes, it's actually supported with any import data source. Any import data source. However, the ones that are going to be best suited for it are the ones that support query folding, right? Because then the data source is going to deal with the filter for each partition. So absolutely Oracle would qualify, right? So those data sources that support query folding will come back with just the required data for each partition. Even if the data source didn't support query folding, it would still work, and it would still only load the right subset of data into the in-memory cache, right? But the queries are going to run faster on the data sources that support query folding, okay? Any other questions? Yes, if you don't mind. Yeah. I should have asked you to just sit near the mic. Yeah.
On GitHub, there's a project called Analysis Service Automation done by Microsoft, one of the guys, I guess you know him. Is that so they share the same code base? Because it looks like similar functionality of splitting the partitioning, automating partition.
So the question was, this is the type of thing, if I understood correctly, that you would do in analysis services, yes. And does it share the same code base? Yes, it does. It's being enabled only in Premium at this time. So defining this policy would only work in Premium at this time, but it's all the same engine as in Analysis Services, which is why we can, open up the Tom API. So yes, it's all Analysis Services based. It's all the same engine. Power BI runs on the Analysis Services engine in the background. So absolutely, yes, if you don't mind.
What do the staff members that want to look at the boards need licensing-wise? Do they have to have the premium license to be able to view all of this, or can they get away with the free?
So you need the premium license to use it, because you can download and install desktop. You can define the policy, but when you perform a refresh here in desktop, it won't apply the policy, right? So when you perform a refresh here in desktop, it will still just load 1 day of data, but then once you publish it to the service, it will perform all of this refresh logic, and you won't be able to publish it to the service unless it's a premium workspace at this time. Okay? So I'm actually going to show you in just a second. I'm going to click on the publish button, and you'll see that only the premium workspaces are enabled. So you do require premium to do the end-to-end flow.
And when they're viewing it through like Teams or from SharePoint, how does that work?
It will only work on premium
So they have
at
to
this
go
time. It's
direct.
got to be a premium instance, I'm afraid. Yeah, you can, if you get Power BI Embedded gives you a premium instance as well, so that's another way of getting it, but it's got to be a premium workspace. Yes, go ahead.
Is it currently or in the future would be supported with Power BI Report Server?
No comment at this time, if you don't mind. Not 100% sure, actually. It may be, it could end up in any of the products that run on the Analysis Services engine, of which there are a bunch, right? And SQL Server Analysis Services, Azure Analysis Services, Power BI Desktop, the service, Power BI Report Server, Power Pivot, and there are probably a handful of others as well. Okay, any other questions? No? Okay, I'm going to move on here. So these two checkboxes down here are more for advanced options. Now, so this one, detect data changes. My connection is a bit slow. This is running on a VM. It's just the UI that's taken a little while to refresh here. So the detect data changes. So we've gone from refreshing 10 years of data every time I do a refresh down to 10 days. Okay, that's great, brilliant. What if I want to go even more efficient than that, and I want to go to just the days that have actually had any data changes? Right? So maybe only 2 of those 10 days have even had any data changes. Only 2 of them need to be refreshed. If my source system has some kind of an auditing column, like a last update date, that I can use to check whether the data has changed, then I can use it here. So I can click here and say, okay, this last update date is an auditing column that every time a record in the source system gets updated, this will have the current timestamp, so to speak. And so if I run a max of last update date for each of the periods or for each partition, and I store the value of that every time I do a refresh, next time I do a refresh, I can run those same queries and detect only the partitions or the periods that require a refresh. All right? This is a more advanced area. You don't need to use it. You need to have the auditing column to be able to use it, but it's there. And then you can go from super efficient to ultra efficient. All right? That's how we roll. All right? Okay. And then, any questions about that? No? Okay, and then lastly, we have only refresh complete periods. In this case, it's saying days, but it would be, if I select months here, it would say months. So this is where, let's say I run my refresh at 5 a.m. every morning, and I've already got some data coming in between midnight and 5 a.m. I may want to exclude that. There are certain business metrics that don't work on partial periods, like barrels per day in oil and gas, or a lot of financial systems publish on, I don't know, the 11th calendar day of the month for the previous month, and there's all these things that you only want to pull a complete period. Again, the details of all of this are in the documentation, which will be ready when this gets released. So these are 2 more advanced options. In most cases, you wouldn't even worry about these 2 checkboxes and you'd be done. Okay? All right, so having defined the policy, I then need to publish it to the service. And as we discussed a moment ago, it will only allow me to publish to a premium workspace. I won't even bother with that right now. This is a pre-build. The actual build will be coming out in the May desktop release. So then the premium the workspace list is filtered only by the premium workspaces, right? And then I perform a refresh. First time it takes longer, subsequent times are much quicker. Okay? That's how you define it. That's how you use it in Power BI Desktop. right? Now I'm going to go one level deeper and show you, I think you might be interested, sir, in how this actually works in the back end and how this will be exposed using our good friends Tom and Timsel, right? Tom and Timsel are like related somehow. I don't know how, but so here I have a Timsel command, and I'm in SQL Server Management Studio. Yes, you will be able to connect to a premium workspace in SQL Server Management Studio. Right? You just connect to it. It looks just like an Azure Analysis Services instance, right? And it lists all of the databases. It's just like Analysis Services. I can now run my Timsel command. This is the complete metadata of the model. It defines all of the tables, the columns, the relationships, the DAX measures. Everything is defined here in this create or replace Timsel statement. And if I come down here, and so if you know Azure Analysis Services, that create or replace Timsel statement will probably look familiar to you. What will not look familiar is the capability to define the refresh policy. Right? This is brand new with incremental refresh. Right? So here I have for the trip table, and in this case, I'm defining the policy right here in Timsel. So if you were to crack open the PBIX, it would actually be saving it in this format in one of the files within it. And so the policy that's defined in that dialog is saved here into the refresh policy, right? And here I have the source expression, which is an M expression that is filtered by the range start and range end parameters, right? So I have this is all I need, and I can set this in Tom as well. The tabular metadata is equivalent to the Tom object model as well. So there'll be a refresh policy class that you can program in C# if you want as well. Now, with this defined, I'm going to go ahead and create this model. And I will now, since SSMS doesn't know about these special policy-driven partitions yet, I've created this little Tom app. So this is just a C# app that uses Tom to connect to the model, and it figures out what are all the partitions in the model. Right? So right now there's only one partition, which is as though I just published it from Power BI Desktop and I haven't run a refresh yet. Right? Then I want to perform a refresh, and now I can use our friend Timsel again. And here I have the refresh command. You can go into SSMS, right-click on a table, say, I think the menu option is process, and it will generate one of these Timsel commands for you. So then this is going to refresh this table for the first time. I'll go ahead and do it. It's not actually pulling any data because we don't have that long to wait for it to refresh. But it will generate the partitioning, the partitions to support incremental refresh, which is what you referred to earlier. So now if I refresh this, we can see that it generated a ton of partitions, and each partition has its own range start and range end values, right? And the latest partition we have is December 9th. And actually, this, if I just quickly show you over here, I've got a timeline storyteller visual that represents this. So this is the way that it does it. It does automated partition merging for improved compression, and in some cases query performance as well. So here I have my incremental range, and it's going to try and merge the days in November as soon as they fall out of the incremental range. So if I move forward, it still can't merge them, and then the next one, it performs a merge, right? So if I come back in here, I'm going to really quickly simulate this. I'm going to change this to, I don't want to spend too long on this, but if I change this, I roll forward one day. And we should see that we have, instead of December 9th, we should be on December 10th. December 10th, but we haven't merged the days in November yet. And I roll forward one more day. And then we should see the days in November merged to the month. And there we go. So again, this is the type of thing that you would do in Tom on Analysis Services, and it was a lot of work. Right? So we abstract all of this for you now. All right? So that's incremental refresh. I'll just quickly show you. I'm not going to demo any more here, but so I discussed partition merging, There's dropping old partitions when they fall out of range, so the old partition for that quarter will drop out of range. It will maintain the minimum data that's required to meet the requirements of the policy, and it will figure out, it will opportunistically drop old partitions and perform merging, and it will recover gracefully from prolonged failures. If your data source credentials expire and it takes you 13 days to figure it out, or your customers 13 days to figure it out, and your incremental range is only 10 days, it will fill in all the blanks, basically. And it will have a big incremental window here, and it works pretty well. Okay, so that's incremental refresh. Any other questions about that, or shall I move on? No? Okay. All right, so that's incremental refresh, Tom and Timsel. Now we're going to move on to, and just to summarize here actually, so the May desktop release, which may come out today, you'll define the policy in desktop. There won't be any round tripping to desktop for now. The dataset size is still 10 gigabytes. We'll be lifting that at some point in the not too distant future. And one restriction right now, that it will stay in public preview until we lift this restriction, which is that if I have my model, I define my policy, I publish it to the service. It takes a couple of hours for the first refresh. Subsequent refreshes are taking 10 minutes. Everyone's happy. I then make a change to the model. I add some new DAX measures, add some new tables. The current publish flow from Power BI Desktop says, oh, you've already got a data set in the service with the same name. Do you want to replace it? Yes or no, right? And if you say yes, it replaces the data set and the data. And if it took you a few hours to refresh the historical data, you don't want to lose that data, right? So we're going to provide the ability to do a metadata-only publish in the not too distant future, and this feature will stay in public preview until we do that. Okay? Any questions? No? Okay. Yes, if you don't mind, sir, do you mind going to the microphone? Thank you.
Good morning. You said about the change of the configuration in the workspace when you are connected. I can change this property only on the script of the workspace in the Power BI Premium, or I have some graphic mode of doing this, or it's only on that script?
Okay, so if I understood the question, it was like you want to change the policy, and what are the options to do it? Do you do it in the script or in the dialogue,
yeah,
for example? Yeah, okay. So you will be able to do it in the dialogue and republish, and soon we'll have a metadata only publish. You will also be able to do it in the Timsel script. You have to bear in mind that if you change the policy, you may lose some data, right? So for example, if your incremental granularity is month, and then you specify a new one that is at the day level, it's not going to be able to, it's going to have to generate a bunch of partitions at the day level, and it's going to lose the month ones. But if you go the other way, it will try to retain whatever data it can it will do a pretty good job of retaining the data. That's the way it's designed. So yeah, there's two ways of doing it, in the dialogue and in the Timsel script. But currently, if you do it in the dialogue, you need to republish and repopulate all the data, if that makes sense. Okay?
Okay, thanks.
Okay, no problem. Any other questions? Yeah, if you don't mind.
Can we control the refresh frequency of the report using this Tom and Timsel?
Okay, so can you define the refresh frequency, how often it gets refreshed? Okay. So you can do that in the Power BI service. You can set up scheduled refresh, and you can, yes, go ahead.
I mean, currently it allows refresh for probably 8 times in a day.
Yeah.
Can we increase that?
Yeah.
I mean.
So I don't want to make any hard commitments right now, but it's quite possible that when we open up XMLA endpoints and Timsel, and you can refresh, in an automated fashion using a Timsel script, that we will lift that restriction, right? I can't make any hard commitments on that right now, but it's quite possible. Okay? Yes, if you don't mind. You know the drill by now, right?
I still want to return back to the partitioning and incremental stuff and the running total quickly.
Yeah.
My experience is that as soon as you start importing pieces of, because we try to make it partitioning manually in analysis services using code. As soon as you start importing batches, and then you need to recalculate running total, you're hitting very high on the memory usage, and sometimes you really easily hit your plan. Even if you have, let's say, 2 giga of data, as soon as you're running total, you get 20 gigabytes in memory in use while importing. Are there any plans to kind of control this and make, because as soon as people start doing more and more refreshes, they'll start hitting this running total calculation peaks of memory consumption.
Okay, so if I understand the problem, I mean, if you're doing lots of refreshes whilst queries are hitting,
can I also give us, sorry, just one example? Because here import will be based on data, on date, as an example.
Yes, only date.
And it means that if I have a billions of rows to import in batches, when I want to hit my kind of the limits of memory, I can try to use it by batches of this size, let's say 10,000 rows or millions of rows. But with the data, I never know how many rows I will import in one batch. Then I easily hit my memory use.
If you want the really fine-grained control for really customized scenarios, you can do it the way you would do it with analysis services using Tom.
Yes.
Right? So you can do that. And really the running total optimization question, I mean, that's really going to depend on the individual model. And there are DAX optimizations. You'd have to look at the DAX query plan. I mean, ultimately, this is getting the data into the in-memory Vertipack cache, right? And when you run a complex query on that cache, then that's a whole nother ballpark. And, you know, Marco Russo and those guys will, you know, they've got DAX Studio and those guys for optimizing those scenarios. And in many cases, it will be an optimization by changing the model. But that's a whole nother topic, if you don't mind. Okay, sounds good. All right. Any other questions, or I'm going to move on? All right, so we've still got 23 minutes, and I'd like to leave some time for questions. So this feature is called aggregations. This feature is pretty insane. This one, you know, we've been dealing in maybe billions of rows so far, right? This thing is going to just blow that out of the water, right? This is going to enable massive data sets in a way that was physically impossible before. In the old days, the laws of physics would not have allowed what I'm going to show you, all right? Assuming all my demos work, all right? So in fact, let me just jump straight into the demo, all right? Okay, so here we have a data set representing data generated by a smartphone app that allows users in social networks to monitor each other's locations in real time. You may know these apps, right? I'm a father and I monitor my kids' locations and that type of thing. Not that, it's just a normal thing to do. Anyway, point being, so these things monitor, these things generate a ton of data. If you think every user is going to submit a location every minute or so, and if you've got a bunch of users, that's a lot of data. So each row in this activity table represents an individual location, all right? And this location count gives us all the count of all the rows in the table, kind of like the New York taxi ride thing. So I'm going to casually drag this onto the canvas. It's Power BI Desktop, the tool I use every day. Everything looks completely normal, and bang. This is, forget billions. We don't deal in billions. I wouldn't pick up a billion if I saw it on the way to work. This is a trillion, right? This is actually a quarter of a petabyte. I know, every time it's difficult to comprehend. I've never actually visualized a quarter of a petabyte, but we're doing it right here in Power BI Desktop. This is quarter of a petabyte of data. If you go and figure out how much data that is, that's a lot, right? That's a quarter of a petabyte is a lot of data. This is coming from HDI Spark, and how long did it take to give me the count of all the rows? It was sub-second. Laws of physics, we brush you aside. You're nothing. You are nothing. We defy the laws of physics, right? This should be physically impossible, right? So how is this possible? I'll explain. Just bear with me. All right. So a trillion rows, quarter of a petabyte of data from Spark, and I have very interactive response times. I'll go with location count. I'll break it out by date. I'll make it a bar chart. I will break it out by occupation. And I just get instant response times. This should be physically impossible, right? This is just clicky, draggy, droppy data analysis over massive data sets, right? Up until recently, this was basically physically impossible. And how's this working? So if you remember, the taxi data set was 1.8 terabytes, right? And it came down to about 50 gigabytes compressed. 1.8 terabytes in its raw, uncompressed form. That compressed down to about 50 gigabytes. So this is a quarter of a petabyte. Even with our compression ratios, as good as they are, this would be a challenge to fit into memory, right? So how is this even possible? So what we're doing is we're caching the data at the aggregated level, right? So we're caching it at the aggregated level, which means we need much less memory, and we unlock these massive data sets in a way that was not possible before, right? And I'll explain a little bit more in just a second. So I'm now going to filter this just by the locations representing the last location in a day where the user traveled over 100 miles. So naturally, we have spikes on Memorial Day, 4th of July, etc. And interestingly, we have this spike here with a lot of student movements on March 27th, which happens to be around spring break. All right? So we'll break out distance traveled. Where's it gone? There it is. Distance traveled, make it a grid, and break it out by this connection slow over the VM. Just a second. We'll break it out by the username as soon as my connection recovers. And then we'll get a list of the students who traveled over 100 miles on March 27th. Okay? Just there we go. Thank you very much indeed. All right, username, bring this over here, assuming it's back again. You know, the queries are so fast that the internet connection can't keep up with them. Right? All right, I need to just filter this. Okay, so here we have a list of all the students who traveled over 100 miles on March 27th, right? This is 1/4 of a petabyte of data. How did we get response time so fast? Because we cache the data at the aggregated level. But what if the user decides to drill down to the detail level where there is no cache? What's going to happen? Is it going to explode? Or does the user need to go and learn Spark SQL? Or do they need to use a different report? No. This is corporate BI. This is a single reusable semantic model that's reused throughout an enterprise organization to promote consistent decisions. So therefore, if the user wants to go down to the detail level where there is no cache, that's okay, but it doesn't have the cache in memory, so it will submit a direct query to the data source. So I'm going to do drill through, and it will now submit. I'm now going to plot the individual locations for this user on this particular day, for this particular student, right? So we're now at the leaf level of, for each location is one of the trillion rows, right? So we're going to have a data point for each of those rows representing a location where the user traveled on that day, right? So we can't hit the cache at this point, which is why it's taking a bit longer, as it's submitting a direct query to HDI Spark, and we'll just check the status of it over here. There we go. Hold on. Okay, let me just refresh this. And okay, so we can see that this query is the query that's running right now. It's been running for 32 seconds. Here is the username that we filtered on, and it's almost halfway through. All right, so it takes just under a minute. This is like a 30-something node HDI Spark cluster. It has 1/4 of a petabyte of data. Every time I do this demo, I scale it down straight afterwards because this thing costs a lot of money to keep running. And so it has 1 trillion rows of data, and it answers this query in about 55 seconds normally. So let me see where we're at right now. It's on 54 seconds, so it's actually done now. So if we come back here, we can see the individual locations for this student on this particular day. Again, my connection is slow, but this student starts off in Lake Havasu. If I drill in, if the connection allows me to, this student starts off in Lake Havasu, hops over to Las Vegas, as you do, jumps on a plane and flies all the way over to the East Coast, and interestingly does not put his or her cell phone in airplane mode, so you get to see all of the locations whilst the plane is flying. And interestingly, the plane actually arrives at its scheduled destination, we assume is Boston. And and then if I drill all the way down, if I'm able to. This student, and the connection's slow, but you'd be able to see that this student ends up just north of MIT, right? So fit in the hypothesis that these are students going back to college after spring break. Point being, we unlocked 1/4 petabyte of data. We did interactive analysis over 1/4 petabyte of data. This is something that was physically impossible to do it like this up until now. This feature is called aggregations. It's going to ship around this summer. How do you define this? I've got just enough time to show you. Actually, I'm going to switch back to the slide since the connection is so slow. So basically, if you know about Power BI, we allow direct query and import, right? And it's a binary decision today. So import caches the data into the in-memory VertiPack cache, and you get blazing fast performance, right? If you have too much data to fit into memory, or you don't want to pay the cost of refreshing that data or the maintenance of it, you can go with direct query. But that means every time the user interacts with a report in Power BI, it will submit a DAX query to the engine, which will then translate that to the native HDI SQL dialect in this case, and submit and it's the M Power Query engine that does all this work. It then submits that query to the data source and retrieves that data. Now, the problem is that that's a lot slower for interactive analysis. The direct query means you're at the mercy of the data source to return that data for you, right? And I plotted 300 data points from a trillion row table. That first aggregated cell value would have been a sum of all trillion rows. It would have had to query all trillion rows, which would have been really slow, right? So direct query has some performance limitations, and currently it's either import or direct query. You can't get the best of both worlds, right? So what we want to do is allow you to specify direct query or import or the storage mode at the table level instead, okay? So we're doing that this year. This is a pretty big deal. It's going to open up a lot of new scenarios. So today, it's a binary decision. It's either import or direct query. All the white tables are direct query. And soon, you'll be able to, at the table level, specify which one is import and which one's direct query, right? This alone, even without direct query, opens up a bunch of scenarios. There are a bunch of direct query models that you could load the dimensions into memory so that the initial report load is super fast and gives your user a much more responsive experience for near real time and write back scenarios. There's a bunch of scenarios that could use this even without aggregations, right? Then, for aggregations, let's say this table is the sales table has 10 billion rows, right? We can create another table in the model. It's just another table in the model. Even the aggregation table can be in direct query or in import. So I can, I have complete flexibility, and I just manage it just like any other table. It's not like aggregations in multidimensional analysis services that is like a black art that requires you to go through a bunch of ones and zeros to figure out whether your ags are getting hit or not, right? So I create another table, which is simply the sum of sales grouped by date ID, geography ID, right? Naturally, this thing's going to have a fraction of the data in. If the first one had 10 billion rows, this could have like a couple of million maybe, right? Then I set up this aggregation table, and then I tell the engine, this is an aggregation table. You can use it to answer queries to the big detail table, right? So if Power BI submits a DAX query to the engine like this, which just says sum of sales amount, it says, oh, you're asking for sum of sales amount. The user, the DAX even, the query, the consumption doesn't know anything about sales ag table, right? It's completely abstracted, but it asks for sum of sales amount, and the engine says, oh, I've actually got an ag table that is at the granularity that can answer this query because it's by an attribute in date and geography. It says, I'm just going to give you it back straight from the ag table. It's going to be super fast, right? And that is it. Then you submit another, if the user drills down to the detail level where there is no aggregation, where it can't hit the ag, so in this case, we're aggregating sum of sales by customer name. It cannot hit the ag because for a row in sales ag, there will be one row in geography, but there could be multiple rows in customer. It wouldn't know which customer to aggregate to, so it says, I'm going to revert to direct query. It still works, right? But it just runs in direct query at this point. Make sense? Yep. Any questions? No? Okay. And I've still got just over 10 minutes. So the way that we will define this in desktop, we've started building this, and I'm going to actually show you it in desktop, assuming my virtual machine connection doesn't flake out again. But basically, it's just like the incremental refresh dialog. It's just a dialog for a table, right? And I say, oh, this is an aggregation table, and the foreign keys are the group by columns. This actually matches the conceptual model we were just looking at in the slides a moment ago. And then here are my numeric aggregated values. And here I specify, oh, this one's just going to store the count of all the rows for a count rows. DAX function would leverage that. And then we have sum and count. I would pre-compute. I could do it in the ETL. I can do it in the Power Query M expression. I would pre-compute those aggregations when I'm doing a refresh, right? And so some subqueries or some aggregations will leverage this. Some aggregation functions will leverage this aggregation. Counts will leverage this one. Average will leverage both of them because it will internally fold to sum over count. And so even for a complex DAX measure, it gets kind of folded down to the individual sum, min, max, count components, and they will hit the ags as much as possible, right? And these are the ag functions we're going to launch with, right? Any questions about aggregations? No? Okay, so as I say, this is going to be a game changer in terms of interactive analysis over big data. Yes, if you don't mind. Yeah.
Does it also come to analysis services?
Aha,
Because it's always interesting to see which product will be future Microsoft choose to support in the long run.
It will be launched initially in premium only. People just say, oh, it's the analysis services engine, just launch it in all of them. It's not quite as easy as that. I know that a lot of analysis services customers would love this in analysis services, but think about like incremental refresh. You know, we need to, there's a lot of work we do around building the UI and a lot of testing work, etc. So we have to pick one of the products to be the first one to launch the feature in its Power BI Premium. And you know, we only plan 6 months at a time. So I'm not sure if and when it will get to analysis services, but if you request it on user voice on ideas.powerbi.com, I suspect that a lot of people would agree with you, and then we'll take it from there. Okay? Yes,
so will the engine rely on relationships then in the model to figure out?
There are two ways of doing it, right? If you've got a dimensional model like the one I showed, it will rely on relationships, it will leverage relationships, and it will automatically use those relationships to access the dimensionality of all of the attributes of the related dimensions, right? So that you don't need to do mappings for all of those attributes. Now, since you asked the question, some data sources, like the Hadoop-based big data sources, often don't have many relationships in the model. In fact, this is the actual model for the trillion row demo that we just saw. There's this is the activity table with 1 trillion rows, right? And this is the only table in the model. Quite often with these Hadoop-based big data sources, they'll just have one kind of fact table with all of the dimension attributes denormalized into it so that it doesn't need to perform joins in the queries at runtime, because quite often, you know, HDI, Spark, and everything, they can deal with these massive data sets, but they don't deal with joins on the fly that well. So that's often the pattern for these Hadoop-based big data sources. They'll just have these big tables with all of the dimension attributes denormalized into the fact table using the kind of dimensional modeling terminology. So what we would do, we'd create an ag table. So these are the only two tables in the model used by the trillion row demo. So we'll create an ag table with just it's got a sum for the travel distance. The other one was actually the count rows, so it's not a column mapping, right? So there are a couple of true aggregation functions, and then instead of using the group by on the foreign keys, we do it for all of the dimension attributes. We do this column mapping for all of the dimension attributes. This gets us by not having relationships. But if you have relationships and you're on a data warehouse or a dimensional model, then it works with relationships. Okay? So it works in both ways, right? It works for the Hadoop-based big data sources as well as your kind of dimensional models, whether it be Kimball, Inman, or whatever is your favorite. I know it's a bit of a ideological debate, but there you go. Okay, yes, go ahead.
Would aggregations work on the embedded Power BI?
Actually, embedded would get you premium SKUs, so actually it would, yes. I believe it would. We're still about 3 months out, so I'm not going to commit 100%, but as far as I'm aware at this point in time, it would. Okay? Yes, go ahead.
On jQuery, you have some limitations, like, for example, functions of time intelligence in DAX don't work in jQuery. This limitation with this remain the same if, for example, I chose a jQuery for a table. I can't work with time intelligence functions in DAX on this table and other limitations that the documentation specifies.
Yeah. Okay. So as I understood it, the question was, will the time intelligence functions work with aggregations, right? So basically, yes, with a caveat. So it gets, each individual subquery gets folded down to the sum, min, max, or count, right? And then the thing with the time intelligence functions is, like you say, year to date, month to date, it will generate an in-memory DAX table at the day level. So if you have an aggregation at the month level, it will not hit the agg, right? But as long as if you're aggregating like the model that I had that was, it was aggregating by date ID and geography, then that was at the granularity that would hit the agg. If I were to create an aggregation at the month level only, then the time intelligence would not hit the agg. Okay?
Because in most of the cases, you're going to have a calendar table that you're going to use for...
Yeah, absolutely, absolutely. You would use it. So as long as your aggregations relate to the key of the calendar table, then you'll be fine. Okay?
Okay, thank you.
You're welcome. Any other questions? No? Okay, so I've got 3 minutes left, and what can I show you? Let's figure something out here. I'm not going to tell you how little preparation I did for this, but what I will show you, assuming this connection works, is that this whole AGS dialog in Power BI Desktop is not a figment of my imagination, right? It's happening. This is really happening. So here is the same model that we were just looking at, right, with cells and date and bar. Here's my AG table, and if I come over here, I'm going to say manage aggregations, and hey presto, here's the first version that anyone outside the development team and me have ever seen. Here's the manage aggregations dialog. And I only got this build last week, right? So this is very, very raw, but just to reassure you, this is not just a figment of my imagination. I didn't make everything up, okay? only a little bit. No, I'm kidding. This is all good. This is all happening. This is all happening, okay? And we've only got 2 minutes left, so has anyone got any other questions? I think that's about the right point to round it up. So we would very much appreciate you filling in the evaluations. We very much hope that you'll have an awesome build conference, and we look forward to you unlocking massive data sets, accessing any data source, and enjoying it while you're doing it. So thank you very much. All right, thank you.